In this lesson, we're going to be verifying that two functions are inverses. So you'll notice that for problem 1, it says determine whether these two functions are inverses. So we're given excuse me, the function f of x and the function g of x. And to see if they're inverses, one of the cool things that works is we're kind of combining the last 2 days worth of stuff here. But if I find f of g of x and g of f of x, when I put the g of x equation into f and the f of x equation into g, if my answer equals x, that proves they are inverses. So that's one method you can use to see if two graphs are inverses. You could graph them also and double check, but this is a surefire way. So this is one of the methods we're going to learn. So to do that, for each problem, you will actually find f of g of x and g of f of x. If at any time the answer does not equal x, you can say they're not inverses and you can quit the problem. So to start, I would be finding g of f, or f of g of x. I'm going to put g into f, which means I'm going to put this into right here. So I'm going to copy this the same. I'm just going to hit an equal sign and bring this down. I would have 3/4, and then where the x is, I would put in 4/3 x, 4/3 x plus 8, and then minus 6. So as I reduce this and simplify, I distribute here. 3/4 times 4/3 x would just be x. 3/4 times 8 is 6. So I end up with f of g of x, and you'll notice I switched the notation. I don't care which one you use, f, the open circle, or just the parentheses, doesn't matter. When I combine like terms here, I end up with just x. So that's my goal. This tells me, since I got this x, so far we're doing good. Yes, so far they're proven to be inverses. But it also has to fit f of x into g of x. So now, I'm going to erase what I have up here. This is a whole new problem. I'm now going to take the f of x equation, and I'm going to put that into the g of x equation for x. So I'll just kind of bring that down. I have 4/3 times 3/4 x minus 6, and then the plus 8. Again, I'm going to go ahead and distribute here. 4/3 times 3/4 x equals 1x. 4/3 times a negative 6 is, not positive, how about a negative 8, and then I bring down my plus 8. So I have f of g of x equaling x. Again, it worked. So by having it equal it twice, I can now say, yes, these are inverses. Now, a lot of students like to skip some steps in these problems, and normally I'm okay with you skipping work on things if you can do it in your head. This is one area where the only way I know you did it the right way is to show me your substituting and actually show me all of these steps. I realize that's not maybe what you want to do, but otherwise I don't know that you did it the right way, and I can't check that you use this proper method. So I will require you on the test to show me all of your work for these problems. If you would just, let's say, for your answer right here, write, yep, x and x, yes, you would get no credit, because I didn't know if you actually replaced f into g and g into f. So you have to show all of this work. I'm going to let you guys try number 2, and then you can check up here and see if you get the same answer as me. So this looks like we're missing a little circle here, huh? So I'm going to put g into f. So g into f. So I have f of g of x equals 3 times 3x minus 4, and then plus 4. So as I distribute, I would get 9x minus 12 plus 4. So f of g of x equals 9x minus 8. Remember, I need it to just be x, right? So right here, it's not x. I can say no. They are not inverses. I don't even have to do the other one. Don't have to do this at all, because it already doesn't work. So you're done.